Welcome to Study Loop.
So we were drawing a flowchart for the system where we have some missing values. So the first thing we need to do is perform an energy balance on the system. So we have Q dot equal to delta H dot equal to N out, H out. Take away N in dot, H in dot, where this value is equal to negative 1.278 kilowatts. In the second part, we need to calculate the required cooling rate for Q dot using the heat capacity. So we have Q dot is equal to N dot integrate from the limits T2, T1, Cp dt. We find that we get a value of negative 1.267 kilowatts. So next we're looking at the specific enthalpy for each of the stream temperatures. So what we find is we have Q dot value of N dot equals H out, subtract H in. This value is equal to negative 1.275 kilowatts. So the answer in the very first part is the most accurate because these steam tables are compiled from experimental data. So this method will also take into account the pressure change in the system, whereas part 2 based on the mathematical model used to determine the enthalpy, which is used as the equation approximate the behavior of a system. So this model doesn't really take into account the effects of pressure on the enthalpy of a system. And in the final part, this also does not take into account the effects of pressure on enthalpy. So the difference between the values calculated in part 1 and part 2 is due to the enthalpy change from the system pressure going from 10 bar to 1 atmosphere. So the temperature change effects are accounted for in both methods.